Hey there, and welcome back to this course summary on E2015 Electrical Circuits and Networks. And in the last two videos, we studied, revised quickly what circuit theorems we deal with in this course. That is Norton theorem, Thevenin theorem, maximum power theorem, and so on. So in this video, we'll quickly go through what two-port networks are and what two-port parameters are. So without any delay, let's start. So what is a two-port network basically? So it is a network comprising of resistors and uh, dependent sources. There are no independent sources. And this network has two terminals. We take two terminals as in the diagram here. You can see terminal with let's say a port, we can call it a port with terminals 1 and 1 dash, a port with terminals 2 and 2 dash, taken from different nodes from the network. And we have a potential source, a voltage source V1 on the left side, a current I1. Note that I1 is consistent with the sign convention, but the sign convention is with respect to the network, not with the voltage source. And same goes for V2 and I2, which are on the second port. So since the circuit comprises only of linear elements, that is, there are only resistors, dependent sources, and independent sources, the current I1 on the first port can be expressed as some constant times V1 plus some constant times V2. The constants, what they are, we'll find that out. But as of now, it can be written as a linear sum of V1 and V2. This is because, again, linearity and the kind of elements we are dealing with. Similarly, we can write I2 as a combination of V1 and V2, where there will be some constants. The constants are what we call two-port parameters. We'll see soon. And from duality, that is, if we, let's say, simplify the two expressions or solve them again, we'll have V1 and V2 as expressions of I1 and I2. So, uh, we denote the two-port parameters by Z, Y, G, and H. So when I1 is expressed as a sum of V1 and V2, we use the Y parameters. That is we can call them the conductance parameters, let's say. And uh, you can see that I1 has been written as Y11 times V1 plus Y12 times V2. Similarly, I2 is Y21 times V1 plus Y22 times V2. Again, at this point, we can see that this parameter set y11, y12, y21, and y22 can be represented as a matrix, a y parameter matrix comprising of four elements, 2 by 2 matrix. And when that matrix is multiplied by a, a column vector v1, v2, we will get a column vector i1, i2. So again, a matrices will be used here. And after that, yeah, passive sign convention has been followed. And also, I would like to say that y parameters of this network, y parameters are also known as short circuit parameters. And what these parameters mean, we'll just see. Uh, what does a y11 mean? So what is y11? It is I1 by V1 when V2 was 0. So what does it mean? When V2 was 0, that is the second port is short circuited, and when it is short circuited, the ratio of I1 by V1 is called Y11. And what is Y12? Y12 is the ratio of I1 to V2 when V1 was 0. That is, when V1 is short circuited, the ratio of I1, that is current in the first port, to the potential difference across the second port. Again, Y12, again, as you can see that Y12 is basically the effect of I'm sorry, it is the effect on the first port due to something that is happening on the second port, and that too when the other parameter of port 1 was 0. That is, when the other parameter, see, y will be the ratio of I to v. So the other parameter, will definitely be V1. That is, when V1 is 0, the ratio of I1 to V2, that is the effect on I1 by V2. I hope that's clear. And similarly, we can change the parameters we are dealing with, that is v1 and i1, interchange them in the two equations. We'll get different parameter sets. We have three more parameter sets apart from y parameters, that is the z, h and g. For z, you can see the matrix is v1 v2 is equal to z11 z12 z21 z22 times i1 and i2 column vector. And here z will have the dimensions of resistance. And from the two equations which we saw just now, it is evident that the z parameter matrix is the inverse, matrix inverse of the y parameter matrix. Similarly, we can also have v1 i2 column vector, which is equal to h11 h12 h21 h22 times i1 v2 column vector. This is called the h parameter. And the g parameter, where we have i1 v2 expressed as a linear sum of v1 and i2. This time they are called g parameters. So h and g are hybrid parameters because they don't have the dimensions of conductance or resistance specifically. Because let's say if you deal with h11 will be uh, having the dimensions of resistance, whereas h12 is a dimensionless quantity. And for G, we have G11 will have the conductance dimension, whereas G12 will be dimensionless. So these are the four parameter sets that we discuss in two-port networks. And in the next video, we'll discuss a very important property of two-port networks, that is reciprocity. So stay tuned. Thanks for watching and see you there.